This lesson is on how to express a quadratic in standard form or how to change it into vertex form by completing the square. So standard form is our basic ax squared plus bx plus c equation. Vertex form looks like this. The reason it's called vertex form is because you can easily identify the vertex of a quadratic that's written like this. So if I had the quadratic 2 times x minus 6 squared plus 4, my vertex would be 6, 4. Because remember, the quadratics still follow our basic translation rules. When we subtract a value from x, it shifts your graph that many units to the right. And when we add to the value of the entire function, it shifts it that many units up. So it's pretty convenient to have a quadratic in vertex form. The other thing that this is going to do for us is it's going to teach us how to develop the quadratic formula. So we're going to go ahead and go through the process of completing the square. And these are the steps, step 1 through 5. And you want to make sure you follow them exactly. So I'm going to use numbers that aren't super nice just because that's pretty typical when dealing with quadratics in vertex form. So we're just going to start with, we'll start with a lead coefficient of 1 for the first example. So let's say we have x squared plus 6x plus 8. So we want to put this is in standard form, we want to put it in vertex form. So step 1, move c term to the right hand side. So don't break any rules, follow your algebra. So I'm going to subtract 8 from both sides. And leave some space. So I'm going to rewrite it, leave a little bit of space, and keep our negative 8 here. Step 2, factor out our a term. Well, our a term is 1, so in this problem we can skip step 2. Step 3, divide b term by 2 and square the result. So 6 divided by 2 squared. And that gives us 3 squared, which is 9. Add this result to both sides of the equation. So I'm not breaking any rules by adding 9 to both sides. And there's a reason why we're taking these steps. So now, look at this side of the equation. That's an equation that's really easy to factor. And we made that happen by dividing the b term by 2 and squaring it. We didn't break any rules. When we moved this over, we subtracted 8 from both sides, so we kept our equation balanced. When we added 9, we added it to both sides, so we kept our equation balanced. But now I can write this in factored form. What two numbers, when multiplied, give me 9, but when added, give me 6? Well, x plus 3 times x plus 3. It's not a coincidence that these are the same. That's going to happen each and every time, and that's why it's okay to just write it as x plus 3 squared is equal to 1. So if we wanted this in vertex form, we could just move that 1 back over. So now we can see that our vertex is -3, -1. And one of the most important components of a quadratic is being able to identify your mins and maxes. So back to that fencing example we did earlier, that max is going to tell us the maximum area of a fence that we could potentially build. If you're dealing with projectiles, that max is going to tell you how high something goes. So vertex and x-intercepts are the main characteristics that we're focusing on with quadratics. You could also, from this point here, if you needed to solve for the x-intercepts, this is a pretty easy equation to solve. So I have x plus 3 squared is equal to 1. Well, how do you get rid of a square? Take the square root of both sides. So x plus 3 is equal to, don't forget the plus or minus, the square root of 1, which is 1. So I'm going to follow my algebra rules and subtract 3 from both sides. So x is equal to -3 plus 1, which is -2, and x is equal to -3 minus 1, which is -4. So by putting this in vertex form, we were able to easily identify the vertex and the x-intercepts. So let's do an example now where our lead coefficient is not 1. So still going to follow all of my steps. Step 1, move C term to right-hand side. So that gives us 2x squared plus 8x, and I'm going to leave some space, is equal to 6. So remember, following algebra rules, if I want to remove this from this side, I have to add 6. That goes to 0, add 6. So this time we have an a term, so this step is, we have to follow it. Step 2, factor out the a term. It doesn't matter whether or not it factors out nicely. In this case it does, but if you had a 2 here and a 5 here, you still have to factor out our a term. So I'm going to factor out our a term. So I'm going to rewrite this as x squared plus 4x. So I haven't really changed anything other than writing it in a different format. So I factored out a 2. Step 3, divide b term by 2 and square the result. This is our new b term that we're going to divide by 2 and square. So that's 4 divided by 2 squared, which is 4. But here's the tricky part. I didn't just add 4 to this side. I actually added 8. So if I could put some flashing lights as a warning right here, I would, because this is the one step that is so commonly forgotten. I did not add 4, I added 8 because I have this factor of 2 here. So when I add this to the other side, I have to add 8, not just 4. If I had factored out a 3, I would have added 12. So just whatever you are adding to this side, don't forget to multiply by whatever that a factor is. Okay, so that gives us 14. So again, we are going to write this in factored form. So what two numbers when multiplied give me 4, but when added give me 4? Factors would be x plus 2. So last step, we want to get this 14 back over. And there we go. Now it is in vertex form. So you can identify your vertex as -2, -14.